Welcome back, friends. In this video tutorial series, we are building this IoT application. This IoT application doesn't actually have any devices. We have created devices here, but for the purpose of this application, we are going to use it and test it using something that we are adding here called the simulator. The simulator is a way of testing the application. And here what we're doing is we just add a sensor, give it some parameter as to how frequently we want to generate a reading, and give it some conditions like are we going to use a random number every time or a SAW algorithm, and minimum, maximum, etc. we just provide here. So the reason I wanted to show you this is because in today's episode we're going to be building the application, and the simulator is one of the things that's part of the application. So let's just go back to the designer. Before I start building the IoT functionality into our application, I just want to show you some basic characteristics of how the web IDE works. We will be writing all our server-side programs into this IDE. It's fully web-based, and it's connected with your instance. If you sign up on the website ZOAPIIO.io, you will get access to this. So here I've just opened a blank project, and I want to show you some of the things here. You will have to go and read up in detail from the documentation. This is just to get you started. So we have these variables from where you can declare your local variables. Just simply do a new tag. Everything you see on the left-hand side, it's a tag because it's hierarchical structure. You can give it whatever name, and you can give it whatever data type. Everything else is, if you want to have duplicates, check this box and just simply save. This is how you build up your schema. And you can also do an import from an XSD file, you can import from an XML file, JSON file, all those features are available. In the session, you would declare the stuff that you want to keep in session. That means it will be available across different services inside your application. It'll persist across those invocations. Inside the business flows is where you're going to write your programs or your services. So the simplest one is an HTTP entry point, right? You just simply create a new entry point, give it a path, which is the URL by which you will be calling it, and give it some other stuff, properties like where the request is to be extracted and what is the response node, etc. Then you do a save. And to edit the program for this, you do a right click and open the edit. This is your graphical designer. This is where you write programs. We have these commands, okay, and this is completely graphical. You just simply take these blocks, you move them around, and you assemble whichever way you want. They are blocks. You can do iteration, you can do conditions. For example, if I put a condition, and I can just do things, move blocks around. If I want to, for example, add another else if or else, I can just do it here and add more blocks or more. I can add a comment like this, etc. So I'm showing you this to get you started, and when we actually look at the code, you will see. I will not actually be doing all this, but you will have to learn this. It's very easy, and you should be able to learn it in not more than 1 or 2 days. Then some other things we'll be doing here is we'll be adding database tables to our project. So we can do that from here. Right click and just say new database table. Click on this, select the database, select the table name. There are a whole lot of them. and you say save, and then you come here and say import definition. So the system pulls the definition of the table from the server. So this is enough background for you to get started with the web IDE. Now I'm going to resume building our application, which is the IoT application. In the last episode, we had built the structure or the basic structure of the application, which we saw was 100% generated. There is no manual code that we did there. Now what we're going to do is we're going to create another project. And the reason we will do another project is because if you make changes to the same project, the next time we generate, these changes are going to be lost. So we will maintain our application into two separate projects. One we will regenerate whenever we want, and the other where we're going to write stuff that's maintained by us manually. So you see here these tables have already been imported here. Now these tables were already there in the project that was generated, but we need to add them again to this project. We have all these variables declared here. This is our response node. We have an MQ input node. I'll tell you what this is about. And we have an MQ output. So our application is mostly based on queue processing. So here what we are writing is we have one simulator service, which is going to take all the simulators in our application, and for each one of them, based on our configuration, it is going to generate random readings. So this is the simulator service. Then we have these queues. So we have a Q1, which is the main queue. So once a reading is generated either from a live service or from a simulated service, it lands up in this queue. And this is the handler for that queue. It's a program. It's not a very big program, but we have to do so many things, so that's why it looks a little bit long. So we iterate over all the simulator records. So I'll just show you some initial lines, what they mean, and then you can follow it yourself. So first thing we do is we take the input message and forward it to another called the GQ. GQ is our aggregator queue. So every data reading that comes needs to be aggregated. So we simply forward it to another queue, which is doing the aggregation. And thereafter, we start processing the reading. So we fetch records from the sensor, and we check if something was found. If it is not found, nothing to be done, just return. If the sensor is not found, then we have some other processing, and here we are inserting into the sensor data table. So every reading is saved raw into the sensor data. Here we are computing if it is inside range or outside range based on the sensor configuration, etc. We can compute the sensor state, we generate alerts, etc. All that is being done here. You will have to read this program and follow it, and perhaps write it as per your own requirements. Then let's come to the aggregator queue. It's again a program like this using that same graphical logic builder. You can read it and follow it. There is another little tool available here called review, which gives you a readable version of the same thing. This you can copy paste and into an editor also, but the idea is here it's a little more readable. So the actual simulation, okay, now we come to the simulator. So we write here a service, which is a HTTP service, although it's not being called as a HTTP service, but it's a background service. So all this does is it just goes in an infinite loop and calls a routine called the simulator, and then sleeps for 30 seconds. This is our simulator routine. It scans for all the simulators for which we need to generate a reading, and the reading is due. And we generate the reading, and then this is the command here which says JMS send, the one in purple. It says send the reading to the Q1, which is where we are monitoring the input readings. So it goes, checks for all the sensors, wherever it's due, generate a reading and send. The actual simulation of the reading is being done inside a Java function. And the reason is that because it requires us access to some Java routine like random number generation, etc. And it's a fairly simple and concise reading generator. If you don't know Java, perhaps you can take the help of somebody who can help it out with this. But we don't really expect you to know any programming when building with ZOAPIIO. So now what we have done is we have written the handlers for the sensor queue, the aggregator queue. We also have an exception queue. Exception queue is any time a reading is outside a normal range, it is pushed to the exception queue. And the exception queue handler takes care of generating the alerts, etc. This is another piece of program you'll have to write. So this is, now we have all the elements in place. We have the simulator, we have the sensor reading processor, the exception queue processor, the aggregator. Now what we need is to be able to initiate this service in the background, because the simulator service is not called from outside. Normally the services would be called from outside. But here we go to this declaration section. We leave everything as it is and just add these two lines, that on initialize, and we say spawn the simulator and the trigger service and passing them a blank request. So this is our way of just running a service from inside the server without actually having to call it. So this is our application now. We have a background service which we configured. We have the handlers, the logic for these services. We have the tables imported. We have the data elements, the schema in here, and that's about all the processing part of the application. All of it is the server-side processing. It runs on its own, and that's it. You just take this, go here, do a deploy project, it becomes active immediately, and your IoT application becomes functional. So I hope you have gotten the essential building principles of ZOAPIIO Web IDE. So you build your structure using the wizard, and then you add your application logic from the graphical designer and builder. So our IoT application is not complete yet because we are yet to add the dashboards. So in the next episode, we're going to see how we're going to add the dashboards to our application, and that should be the final step, because then our application would be ready. Thank you for listening. I'll see you in the next episode.